Hi, I'm Aydin Alptekinoglu from Penn State.
And I'm Gerdus Benade from Boston University.
We are honored and excited to be finalists in this competition, and we are here to tell you about our research in close collaboration with a food rescue platform called foodrecovery.org. They are essentially a two-sided platform that facilitates food rescue nationwide, and they do this by first come, first serve matching. What that means is when a donor posts a donation on this platform, nearby recipients get notified, and the first recipient that claims it on the platform gets it. They have recovered more than 81 million pounds of food in 2024, just to give you an idea of the scale of the operation. And there's some evidence that there is inequitable matching on this platform. For example, in Florida, looking at the data over a 2-year period, we found that bottom 60% of recipients in terms of number of donations got 88% of them. And bottom 60% of recipients in terms of weight, pounds of food, got 13% of them. So foodrecovery.org approached us with this problem of improving fairness in this platform. And through discussions, we boiled this problem down to improving Rawlsian fairness in food rescue platforms that do first come, first serve matching. That's the research question that we're answering in this paper. And our core idea to do this is to prioritize select recipients by giving them a head start in claiming donations. So how do we do that? We first formalize the idea of a priority list, which in its most general form, it is a vector of notification times. Each recipient gets a notification time. And in a special case, we analyze the binary priority list. We restrict notification times to only 2 possibilities. Notify now versus later. So just to be precise about the problem we're solving, for a perishable donation with a certain deadline, we set the notification times to maximize the minimum value, which is what the worst off recipient gets, subject to a waste constraint. The probability that no one claims it by the deadline is less than some number. Assuming each recipient I has an exponential response time with a certain rate, and these value functions are critical, and they can be based on number of donations, pounds of food, fill rate, food preferences, etc. So it's quite general. And they're obviously a function of past claims as well as the probability of claiming the current donation.
When it comes to designing optimal priority lists, 2 things matter. First, the speed at which a recipient responds once they receive a notification, and second, the value of their historical allocations. I'll quantify the latter with XIZ, the fraction of the new donation that recipient I requires to reach total value Z. The optimal thing to do then is to prioritize recipients in decreasing order of the ratios XIZ divided by lambda I. This allows us to prioritize slower recipients, since they will have small lambda i's and therefore large ratios and high priority. Similarly, we prioritize those with small historical allocations. They will have large XIZs and large ratios. For end-stage priority lists, this ordering is optimal. And for binary priority lists, we show that the optimal priority set is a prefix of this ordering. Once we have these, we can find the optimal notification times in polynomial time. Okay, so what is the impact of these optimal priority lists? We run simulations calibrated by historical data from Florida. For a wide variety of valuation functions, we see a 20 to 25% improvement in Gini scores. The Lorenz curve here shows improvements throughout. For example, the bottom 60% of recipients used to receive 10% of donations. When using priority lists, they instead receive slightly more than 20%. Zooming in on the value provided to individual recipients, we see that only the top 20% are worse off when switching to priority lists. The bottom 80% improve. In fact, the worse off you were under the current first-come, first-served system, the more you stand to gain. Our theory permits several extensions. One is particularly important for practice. We can allow upper bounds on the amount of delay in any notification. This is important because priority lists do have the effect of increasing the average time it takes a donation to be claimed. Our theory allows us to optimally trade off increases in average claim times and improvements in fairness. Let me conclude. We show that priority lists are effective in improving a wide range of fairness-related metrics without increasing waste. Our algorithm is currently being piloted in 2 counties in Florida with an eye towards eventual national rollout. Thank you.